Welcome to the video. My name is Pushpender Gill and this is going to be my email address. So now we're going to do a set theory question, the question which has 5 variables, right? Okay, so often, many times you get this question with 5 variables, you get shocked. Oh my god, what I'm going to do? I don't know what to do in such kind of questions. I don't have any formula. I don't have anything like that. But there is a very structured approach that you can follow in such type of questions. Let's see one of those questions so that you can understand in a better way. So out of 100 students, 90 like cricket, 80 like football, 70 like hockey, 60 like basketball, 40 volleyball and 10 tennis. So there are a lot of permutations and combinations in which what can happen. There will be people who like only cricket and football. There will be people who like only hockey and basketball. There will be people who like exactly 3, exactly 4 and stuff like that. So you don't have to fall for that trap. You just see what the question is asking for you. Now let's pick up one of the questions. Let's say, okay, find the maximum number of students who like exactly 5 out of 6 games, right? So let's see. So what you have to do is you have to make this chart, right? You don't have to make such a good looking chart. You can just draw a few lines and say, okay, all right, this is cricket, this is football, this is hockey, this is basketball, volleyball and tennis, and 90 people like cricket, 80 people like this and all that, and a maximum of 100 people are there, right? So let's see the question. The question is asking what is the maximum number of students who like exactly 5 out of 6 games. Now we have to say maximum number of students who like exactly 5 out of 6 games. So let me say how many people are there. These are 40 people, the people who like volleyball. Let me call them group number 1, right? Let me say, okay, these are one particular group of students. So these are the one who like volleyball. Let me say these are the people, same over here, 40 people who like basketball as well, the same number of people here like hockey as well, the same number of people here like football as well, and the same number of people here like cricket as well. So that means I can say, alright, so these are the 40 people, the group number 1, who like 5 games: cricket, football, hockey, basketball and tennis, and volleyball. So you see, I got my answer as 40. Now hold on a minute. Now there is this guy called tennis as well, right? There is a sport called tennis as well, and there are 10 people here who like tennis. What if I say 10 people here like tennis and the same number of 10 people over here like basketball, same number of 10 people here like hockey, same number of 10 people here like football, and same number of 10 people here like cricket. So I can say that there is another group of 10 people who exactly like 5 games. So just try to understand. I'm trying to maximize a number. I'm not giving you a definite answer. I'm just trying to maximize a number. So that means the maximum number of people who can like exactly 5 out of 6 games from this question is 50, because there is no other group left to be considered, right? Yeah, I have some people left from here, from here, from here, from here, but I have no people left from here and here. That means yeah, the number of people who exactly like 5 out of 6 games are equal to 50. I hope you understood what I did over here. Let's try to use the same approach in our next question. So in this question we have to find the maximum number of students who like exactly 4 out of 6 games. So whenever you have to find exactly 4 out of 6 games, you start from the 4th thing from the top, that is basketball. So you start with basketball. So in basketball there are 60 people, right? Let me say the same group of 60 people like hockey, and the same group of 60 people like football, and same group of 60 people like cricket, right? So I have made myself a group of 60 people. Now can I make another group? So if I want to make another group, let me look at volleyball. So how many people can I spare from volleyball? You see, hockey has only 10 people left. So let me try and say, okay, these 10 people here like volleyball, and the same number of 10 people like hockey, and the same students like football, and the same students like cricket. So yeah, I have made myself another group of 10 people. Right? Now can I make another group? Yes, of cricket, football, volleyball and tennis. That's again 4 sports left. So I can say these 10 people like tennis, and these are the number of people who like volleyball, and the same people like football, and the same people like cricket. So yeah, I can say that a maximum of 80 students like the 4 out of 6 games, exactly 4 out of 6 games. You see how easy it was for me? You just have to follow the basic steps. So if he asks you exactly 4, you start with basketball. If he asks you exactly 3, you start with hockey. If he asks you exactly 2, you start with football, right? And then you work your way forward by going one step at a time and going to the next game and solving the answer, right? So this is a very easy approach which will help you to solve the answer. So first I was able to make a group of 60 students from basketball, and the same group I was able to identify in cricket, football and hockey. Then I was able to make a group of 10 students from the volleyball and 10 students from the tennis, right? So let's go ahead and solve the next question. Okay, now in the next question we have to find the minimum number of people who play cricket, football and hockey. So we have to find the minimum number of people who play cricket, football and hockey. So till now we were finding the maximum number of students. Now we have to find the minimum number of students. So the type of strategy, the strategy remains the same. It's just that the approach changes. The approach of the question changes. So we have to find the minimum. Let me show you what is the difference between a maximum approach and a minimum approach. So let's say this is like the number of students. Let's say 30 students like A, right? And let's say this 10 students like B, and there are a total of, let's say, 50 students. So if I have to maximize how many students will like both the products, so what I'll do, I'll club this 10 in between this, just the way I was doing it. But if I have to minimize that, okay, what is the minimum number of students who will like both the products? So what I have to do, I have to maximize this area. I have to put this 10 here like this, and I have to say, okay, this is the 10 students, so that means the minimum number of students who like both the products is 0, because I have to minimize it rather than maximizing it. Now let's try to use the same approach over here as well. We have to find what is the minimum number of people who play cricket, football and hockey. So this is cricket and this is football. Now in football there are 80 people. So how I can place this 80 people right over here so that there is a minimum intersection? That would be done this way. If I do it this way, okay, I can say, okay, these are the 80 people for cricket. So these are the 80 people for cricket. That means 10 people lie here and 70 people lie here. So the minimum intersection between cricket and football will have to be 70. Beyond 70 it is not possible, because we have a restriction. The total number of students are 100. Now let's try to put hockey into that as well. Now hockey has a total of 70 students, right? So I have to put the 70 students in such a way so that I minimize this area, right? I have to minimize this area. So that means I have to put the 40 students in such a way, right? So let me say, okay, this is hockey. Let me say 70 students are here. So from here to here I can put how many students? I can put 20 students. So I'm left with, from here to here I can put how many students? I can put 10 students. So I've put 20 students here, I've put 10 students here, 30 students have gone. I've got no choice but to put 40 students here, right? So that means the minimum number of people who play cricket, football and hockey are 40 people. The 40 people are the people who play cricket, football and hockey, I'm sorry, right? So this is the way you should do this question, you know. This gives you the answer, right, in a very efficient manner, rather than you trying to build up equations and, you know, trying to solve that way. Believe me, that will be very difficult to solve, right? So I hope this approach is able to make you understand how to solve a set theory question with not even 5, with even 6, 7 or 8 variables. Fine. Okay, let's see the next question. Now in this question you don't have to find the maximum, you have to find the minimum number of people who play cricket, football and volleyball. So if you have understood that approach in the previous question, you can apply the same approach here but in another way. Now you have to find the minimum number of people who play cricket, football and volleyball. Now this is cricket here, this is football here and this is volleyball here. So there are 40 people here, there are 70 people here and there are 90 people here. Now try to do one thing, try to club 90 and 70 in such a way so that the intersection is minimum. So how would you do that? You will say, okay, alright, let me do one thing. Let me say these are those 70 people, right? Okay, these are those 70 people. It clubs like that. So that means this this 10 is left out here, and the number of people which minimum who like cricket and hockey is equal to 60, right? If I had to maximize it, I would have clubbed this within itself, right? So the maximum would be 70, but the minimum is 60 because because the total number of students is 100, and I have a restriction that total number of students cannot exceed a number of 100. Now I have to squeeze in volleyball as well. I have to squeeze in 40 somewhere. So where shall I squeeze 40 in? Now if you see, if I squeeze 30 people here, now I have to see minimum number of people who play cricket, football and volleyball, right? Minimum number of people who play cricket, who play football and volleyball. Now if I squeeze these 30 people here, okay, let's say these are the 30 people which are squeezed here, and I squeeze these 10 people here, right? Okay, I squeeze the 10 people here. So am I able to make, is there any intersection of number of people who play cricket, football and volleyball? Is there any intersection? No, there is no intersection of cricket, football and volleyball, because this is the intersection of only football and volleyball. This is the intersection of, what do you say, cricket and football, and this is the intersection of cricket and volleyball. So the minimum number of people who play cricket, football and volleyball is 0, right? I can reduce it to 0. The maximum would be different, but the minimum is definitely 0. So I hope you're understanding my point of what I'm trying to establish here. This approach will really help you to understand these kind of questions. Fine. Okay, so this was a question asked by one of the students, and I would like to thank that student for asking me that question. And this is going to my email address. You can send me your valuable feedback and you can ask me as much questions as you want. So this will be it for the video, and thank you very much, and see you next video.